Multiply and divide. Before we get into it, we need to go over just a little bit of geek stuff. Right here, two things next to each other almost always means multiply. So we look at our first example, 2 next to 2, that means 22. Doesn't mean multiply. That's why I say almost always. So 22 equals 22. No surprises there. Don't worry, won't get too geekish on you, but we will now, because one thing about geeks is that they love to abbreviate. Everybody, teachers, of course, are guilty of this too. We love our acronyms. We like shorthand. That's what's going on for mathematicians. Instead of always laboriously writing out a time sign or a dot, because, that might also get in the way of the beauty of the notation in some people's minds. Well, we can use parentheses. There's others, but you don't have to worry about them till later on. Brackets, braces, so forth, but let's just look at parentheses. 2 next to parentheses means 2 times whatever's in the parentheses. So this problem is 2 times 2, which is 2 times 2, which is 2 times 2. Same thing down here. If we have 2 signs next to each other, that means they multiply. So negative negative 2 is the same as negative times 2. Just a matter of notation. You could also put dots in here. You could also use parentheses if you want. Wrap everything inside parentheses, stick those parentheses next to each other, and that means multiply. Okay, and down here, our last one, positive 2xy is positive times 2 times x times y. So, little bit of notation. Multiply and divide using doormat. Division, order, reverse, mash all tags. Nope, negatives. Negative, odd, positive, even. Let's focus on nope. Over here, count all negatives in times or divide part of the problem. And then, with the count of the negatives, we'll figure out what the sign of the answer should be. And notice we are counting only the negatives. You can ignore the positives. Negatives reverse things. Positive just means keep going in the way you're already going. Just stay normal. Don't do anything else. If you're in reverse, just continue reverse. If you're forward, continue going forward. They don't do anything, so you can ignore them. So negative equals negative. Odd, answer's negative. Negative, negative, even. Therefore, the answer is positive. Negative, odd, positive, even. I think you can see the pattern all the way down. 3 is odd, answer's negative. 4 is even, answer's positive. 5 is odd, answer's negative, so forth. 6. You won't get this many signs, but I'm just trying to prove the point. And these are all solely multiplication. These have a mix of multiplying and dividing. Here, again, same thing. 1, odd, negative. Here we have 2 that are being divided, a negative, and you could have numbers in here or they could be in front of a single number. It doesn't matter. It's all the multiplying, dividing part of a problem. So a negative number divided by a negative number is positive because 2 negative is even, therefore answer is positive. Same way here, I've got multiplying going on here because they're right next to each other. So negative times negative divided by negative, well, fine. Multiply, divide, division is just reverse multiplication. They all go together. I count my negatives, 3, it's odd. My answer is negative. And same way down here, multiplying and negatives, so I've got 4 negatives, even, positive. Here I've got 5 negatives, odd, negative. Here I've got 1, 2, 3, 4, 5, 6. It's even, therefore my answer is positive. Nope, negative odd, positive even works as simple and straightforward as that. We're still on multiplying and dividing, but I have put this lesson in here to relate it to combining. And if you notice, if you've seen the Colt video, well, these are the exact same set of problems. I am focused on this, count all negatives in times or divide part of the problem. So it's easy when everything's being multiplied or divided, but what if some is being add subtracted and others are being multiplied? How do you tell the difference? How do you keep the signs straight? So here's another one of those exceptions. When I say almost always, what do you do with 4 negative, 4 minus? Is 4 next to the negative, does that mean multiply? Nope, it does not. It means the term stops. Whatever you were doing, the unit, that little group of symbols you were working with, that's separate. Now a new one is starting. So I look at the blank 4, the positive 4, separately from the negative 7. We have 2 parts to this problem. They are divided there at the term boundary, just like that. So I only count these 2 negatives to figure out what the 7 is, and I only count what's in front of the 4 to the left of the 4 to figure out the 4. Same way here. So -8, 1 is odd, so the -8 just stays a -8. No question there, obviously. But now I have a plus minus 4. This is all a multiplying unit because it's a positive times a negative times a 4. So in that whole multiplying part of the problem, I have to count all the negatives in there, which is 1, which is odd. So all that is, that whole part just boils down to a -4. Same thing goes on here. Whatever we were doing with the 9, which really isn't anything, it just stays that way, it stops, and now another term starts. And now we see minus times a positive times a 7, 1 negative, odd, -7. Same thing here, -3 stays a -3, obviously. And now, like a lot of books, if adding a negative floats your boat, if plus a -5 floats your boat, it seems to float some people's boats. I honestly do not get it, because a plus a -5 is really just a -5, and now you know how to do that. Colt, put the biggest number on top. Signs are the same. You're going to add them bigger. You're going to get a -8. So I don't know. I don't know why those other complications are in there. Extra unnecessariness. So again, +11, +11, negative. So we have 2 negatives being multiplied with the 2. Even, positive. That's all we've got. +2. And now you can see it boils down to a simple combine problem. So follow the Colt steps and you're good. Now, just to prove the point, I would do this sometimes with my students. Again, just to prove the point. I try not to be desperately wicked. Once in a while, I suppose I can get that way. But just to prove the point, I've got all this stuff in front of the 2. And I have 1, 2. I've got 1, 2, 3 odd negatives. Notice, ignore the positives. They don't change anything. They just say carry on as normal. Whatever direction you're going, carry on. So negative, 3 odd, -2. Same way here then. two negatives, even, so it becomes positive. So you can see the same principles hold. It just starts looking a little bit more complicated because now it's like there's two little multiplying parts that you have to figure out. And then, oh, this is really just a combining problem. So just work step by step, figure out the notation, and then it reduces itself to a fairly simple problem. We are still looking at mud, multiply and divide using doormat, division order reverse, mash all tags. And that is the focus of this part. We calculate the front numbers as usual. We mash the tags separately. So here's some examples of what I mean, and here's some more explanation. When we're multiplying, mash the tags by putting them next to each other, because putting things next to each other just means multiply. Then you can see if there's more you can do. Our first problem is 4x times 3y. This is 4 times x times 3 times y. Oh, and order doesn't matter when I multiply, so I could just as easily think about this as 4 times 3 times x times y. Well, what's 4 times 3? I know that. It's 12. And then I'm left with the x times y. Well, what is x times y? I don't know. They haven't told me what x is. It's a number. It's an unknown number. There's a number hiding invisibly inside that x, and there's a number buried inside that y, but I don't know it yet. I have to figure it out, or somebody has to tell me, and I don't have enough information to figure it out, and certainly nobody's telling me. So x times y is xy. We just write it as simply as possible. Technically, yeah, you could put a dot, but, you know, we want to make this look elegant, and geeks like things as streamlined as possible, even to the point of cryptic. So just remember that 12xy is the same as 12 times x times y. But you got to admit, it does look simpler and cleaner. Okay, next problem, 2 times 5x times 3m. Well, everything's being multiplied then. 2 times 5 times x times 3 times m. Oh, 2 times 5 times 3, 15 times, or 10 times 3 is 30. And then we've got x times m still to deal with, and again, we don't know them. What I will do is put them in alphabetical order. And again, that's a geek notation thing, but it is also just a standard way of doing it so that you can get used to keeping things in alphabetical order. That will help you later on as things get more complicated and you get numbers and exponents and variables flying all over the place. You can see if you're missing something or not. So yeah, stay in alphabetical order. Highly, highly, highly recommend it. Okay, let's throw in a little division. 21 times y divided by 7. Well, order matters, so I can't go 7 times 21 or 7 divided by 21. I have to keep it 21 divided by 7, which is 3. And now 21 times y, well, again, I don't know y, so I just leave the y there. And so here's another way of looking at it. 21 divided by 7 times y. Well, what is 21 over 7? That simplifies to 3. So you're mashing tags. In a way, we're multiplying numbers, and we're able to get them to a single number. All I can do is mash variables together, and then I just have to stop because I don't know what the variables are. If they give me numbers, I'd be able to multiply everything into a single number, and that would then look really elegant. But they didn't tell me. So I mash them, and I do what's the best, put them in alphabetical order. That's all I can do. I stop. I'm done. That's the answer. Seems strange, but it's algebra. Get used to it. We'll see this more, and don't worry, as we Keep going forward. This will start looking normal. And there'll be reasons for it. I'm trying to stay focused on just basic multiplying and dividing here. Here we go with our last one. 24 times x divided by y. Everything's divided. So order matters. So everything has to stay down here on the bottom. That starts out on the bottom unless things might cancel out. I don't know what x is here. I don't know what x is there. But I know it's the same number. And any number divided by itself is going to be 1. And 1 times anything I get for this is going to be this. So I don't have to worry about that anymore. So now I've got 24 divided by 8. Treat my numbers as normal. 3. I have a y, and nothing else I can do with that. 3 times y. And I got an I on the bottom. Nothing else I can do with that. So I just leave it there. That's as far as I can go. You're done. Welcome to algebra. We go deeper into multiplying and dividing using doormat, and we encounter division order reverse. We're going to focus mostly on order in this section. The next one will cover the reverse. That doesn't make quite good English, but it's just an easy way to put it together and remember it because, doormat. So division order. Order matters only in division. And here's what I mean. 3 times 8 equals 8 times 3, because no matter how you do it, you can see you get 24. You get 24. You haven't changed the value of the problem. The one big thing we are never, ever, ever allowed to do, we cannot create nor destroy energy. We cannot create nor destroy value. But if I can rearrange stuff, well then, fine. 3 times 8 equals 8 times 3. No problem. 24. However, 3 divided by 8 is definitely not the same as 8 divided by 3. Check this out on your calculator. 3 divided by 8, that is some fraction or decimal smaller than 1. 8 divided by 3, that's a fraction or decimal bigger than 2. There's no way that these two sides equal each other. Order matters in division. And if you have seen the graphic video where I showed the 4 operations visually on a graph, you'll see why, because division always has the rectangle area first divided by a side. And you can never go a side divided by a rectangle. That doesn't make sense. It must always be rectangle divided by side. So that's why. But here we're not looking at a graph, we're looking at numbers. So now you can see it from a numerical point of view. It just doesn't make sense. Down here, 2 times 5 times 6 equals 5 times 2 times 6. Or 6 times 2 times 5, or 6 times 5 times 2. Whatever order you want to put them in. Doesn't matter, because I'm always going to get 10 times 6, 60. Here I've got 60. No matter what order, you're always going to get 60. Punch them into your calculator, any order you want, you always get 60. But when we divide, prove it on your calculator, think about the fractions. 12 divided by 4, we know is 3. 4 divided by 12, well, that's 1/3. And there's no way that 3 equals 1/3. Nope. No can do. Doesn't equal. Division only. Order matters. Okay, we are still looking at doormat. Division order reverse. Now we're going to start introducing this idea. So here's a simple exercise. Try this on your calculator. 1 divided by 100 gives you 0.01. Now 1 divided by 10, it's a smaller number, but notice the answer gets a little bigger. Now 1 divided by 1. 1 is smaller than 10, but notice the answer gets still bigger. Now make it smaller. We've gone from 100 down to 10, down to 1, down to 0.1. And now our answer gets even bigger. As the divisor went down, as the last number went down, which would be the denominator in the fraction. I'm looking at all of this. As the denominator gets smaller, the value, which is the answer of the whole division problem, gets bigger. And if we wrote this out in fractions, which we can do here, if we wrote this out in fractions, we'd see that. So let's just take 1 over 100 equals 0.01. That's pretty small, right? But now what about 1 over 100th? Got that TH on the end. 1 over 100 gives me 100th. 1 over 100th gives me 100. So the divisor, I mean, this looks big, 1 over 100, but that's smaller than the same number, 1, in both cases. When 1 is divided by a smaller number, my expectations have to get reversed. I'm going to get a bigger answer, not a smaller answer. And here, if I make the number bigger on the bottom, I think, oh, I've got to get a smaller or a bigger answer. Nope, it's because you're dividing. This dividing reverses all of your expectations. So dividing by a smaller number makes the fraction bigger. Dividing by a bigger number makes the fraction smaller. We have to wrap our minds around it, and once you do, that helps you with everything else. And dividing is the reverse of times, and so big, small looks reversed. We'll get into some practical problems to illustrate that. But hopefully now, just with you and your calculator and looking at this, just division by itself reverses what you think ought to happen. And that's why division reverses things. Okay, still more dividing. Doormat, division order reverse. And so now we will look at actually solving problems. So we know that division reverses our expectations of how things usually work. You know, if you add a big number, you expect a bigger answer. If you multiply a bigger number, you expect a bigger answer. But all that gets reversed when you divide. So let's look at this first example. 3 divided by 8. I can reverse my division problem into a multiplying problem by making another reverse. And that is where we have change needs counter change. So I don't like the division problem. I don't know how to solve it, or I just want to do it in an easier way. Fine. You can change it. But remember, you can't change the overall problem. Can't change the value of the problem. So if I want to change division to multiplying, there's a price to pay. I have to reverse something else. So I reverse my 8. It will always be, I've got it over here on the left. We'll flip the last, or we'll negate the last factor. And I'll show negate later. So 3 times 8, 3 divided by 8 is the same as 3 times, flip the 8, 1 over 8. Remember, there's an invisible 1. Every whole number has an invisible 1 underneath it as a fraction. I'll show that in the show action when we get there. So a reverse and a reverse together, and fine. Check all these out on your calculator any way you want to do it. You always get the same answer. So this works. We have a reverse, and that we are allowed to do because we reverse the last part of the division. Same thing going on down here. 3 divided by 1/8 is the same as 3 times, there's a reverse, 8 over 1. There's another reverse. And it's the last part of the division. I don't flip the 3. I flip the last part of the division. I flip the 1/8, and I get 8 over 1. And so once again, put even that on your calculator. You'll get 24 all the way across, and you can prove to yourself this is the way you do it. So reversing and reversing together. I can make a change if I also make the proper counter change. So here's one with negate. So 2 over 3 to the negative 2. Well, that looks kind of nasty. And in fact, I don't even know how to deal with a 3 to the negative 2. I want to change it to a 3 to a positive 2. Oh, 3 squared. I know what to do with that. That's 3 times 3. That's 9. But how do I get from 3 to the negative 2 to 3 to the positive 2 over here? Well, you can see I am negating my last part. It's on the bottom of the fraction. I'm negating that exponent. So that's a reversal. So I've got to make another reversal so my division turns into a times. And that's how I am allowed to do that. Now I know what to do, because 3 squared is 9. 9 times 2 is 18. Again, put everything in your calculator. Any way you do it, you always add up you always come out to 18. So the value never changed. Our change was always properly counterchanged by reversing in the last factor. The bottom factor depends on how you got it written out, but I think you get the idea. You will flip the last, or you will negate, and that's what lets me do that.